Here we go, round 4, logarithms and exponential functions. So I am going to give you a disclaimer before we jump into this video and these exercises. Some of this may look familiar to you and some of it may be totally brand new, and that's okay. What I want this topic to be is more of a quick overview so that when we get into next year and you see the word log, you don't panic, right? You've seen it before. So I don't expect you to get 100% mastery on this Khan Academy or to feel really, really confident with these yet. I just want you to recognize them, to be exposed, and to have really good notes in your notebook so that when we do get to them next year, you feel confident going back to those notes, finding them, and using those as a support. Okay, so let's get started. The first skill that we're going to look at with logarithmic and exponential functions is how to take an equation and write it in logarithmic form, and then how to switch it to be exponential form. And rewriting these equations is going to be really helpful to us in a number of situations, which you're going to see throughout the rest of the video. So logarithmic form, let's go over some vocabulary here. This top one is logarithmic, and we would read this as log base A, so A is your base, of x, we call this the argument, equals y. This is saying log base A of x equals y. Okay. Down here, I have an exponential function, and I know that it's exponential because I have a variable in the exponent. Okay. So the way to switch between logarithmic and exponential, there's a little trick that I like to call the wraparound. Okay, so I wrote the same equation in logarithmic and in exponential form, and I want you to look at the colors, match the colors, and see if you can figure out a pattern here. And hopefully you found it. If not, I will show you. This little trick is called the wraparound. So when we do this, we start with the base always. And what this statement is saying is A to what power will give me x? Or A to the y equals x. Okay? This A and this y and this x, they can all take turns being variables or numbers. It does not really matter. So we'll look at a couple of example problems. But when we're rewriting this, start with your base. You're going to wrap it around to what's on the other side of the equal sign, and that becomes your new exponent. So equals exponent. And then it comes back around, and your argument is going to become what you're solving for in your exponential. Okay? So let's look at another example. If I had log base 2, 32 equals x. Okay. What this is saying is we're going to start with the base, just like we did up here. It's saying 2 to what power is going to give me 32. Okay. And then think about the idea of an exponent. Remember, exponents are repeated multiplication. So this is saying, how many times do I multiply 2 times itself to give me 32? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I used 5 2's, so that would mean that my x must equal 5. Okay. Sometimes you'll see it written with that x, or sometimes you'll just be able to see this and say, oh, that means 2 to what power gives me 32? I can simplify this to be 5. So log base 2 of 32 is equivalent to 5. Let's try 2 more to make sure we've got it. So log base 25 of x equals negative 1/2. Rewriting this in exponential form, I'm going to start with my base that is 25. So I'd have 25, I'm going to do my wraparound, to the negative 1/2 is equal to my argument, which is x in this case. Now, a little review of exponent rules. Hopefully you remember your exponent rules. A negative means that this 25 is going to move to the denominator, and the 1/2 is a square root. So this is really the same as 1 over the square root of 25. If that just confused you, go back and research your exponent rules. Okay, the negative again moved it to the denominator, and the 1/2 gave it the square root sign. Then 1 over the square root of 25, the square root of 25 is 5. So x must be equal to 1 over 5. We can also go the other direction and take a logarithmic function, an exponential function, and make it logarithmic. Here's how we would do that. You can kind of use the same idea as a wraparound. Here's how I do it. I know that my equation is going to have this form. Right? I have 3 blanks I have to fill in. It's going to start with the log. I'm going to have a base. I'm going to have an argument, and I'm going to have something on the other side of the equal sign. So still using that idea of a wraparound with my exponential, right? I just write them in that order. It has to go A, X, Y, fill in those blanks. My base must be A, my argument must be X, and this must be Y, which, as you can see, matches up here. Okay, so see if those colors help you. Okay, so let's do a real life one. Let's say 5 to the 2 is equal to X, and rewrite that as a log. Okay, so I would have log, I start with my base, I wrap it around, so X would be the argument, and it would have to equal 2. And there it is in logarithmic form. And that won't be as common in an actual problem where you're trying to solve for X, but you will see it a lot as an isolated skill. And by that I mean they're asking you to rewrite it in logarithmic, and this would just be your final answer. Our next skill involves a really special number that is very similar to pi. So we know that pi is really a symbol that we use for 3.1415 and on and on and on, right? It's a common ratio. So we also have another number that is similar to pi that happens all the time in nature. And it's really interesting, and I linked a couple of cool videos if you're interested about where this number comes from and what it represents and what it does. But for our purposes, I'm just going to tell you that this number here, 2.718281, and that bar means that repeats. So really this is 2.71828182818281 going on for infinity. This, instead of writing that out every time, we use it so frequently in nature and in mathematics that we have decided to just call it E. Okay, that is an E, and I kind of write it as a cursive E, not to confuse it with a variable. Okay, and if you look on your calculator, it's generally right around the pi button. There is a button on your calculator. So see if you can find it on the TI-84 Plus. It is right here. It's over the division sign, okay, which we'll be using that a lot. So check that button out, okay? So that's E. The reason we need this is because we have two really common logarithms where their bases, we use them all the time, okay? So the most common log is actually called the common log, and that is a base 10. So log base 10, in mathematics, we use log base 10 all the time, okay? And we use it so frequently, it's kind of like that square root sign. You know how the square root sign is, there's technically a 2 there, but we use it so frequently that we don't write that 2, it's just assumed. Same here. If you ever see something that does not have, a logarithm that does not have a base, like if you just see log 5, that base is missing. It's not 0, it's not 1, it's actually 10. Because we use it so frequently, we can just assume that if we see a log without a base, it is the common log, and our most common base is 10. Okay. Our second most common base in nature and in math and in coding and all that cool stuff is E. Okay, so if we have log base E, okay, log base E, like I've just said, we use it in nature a ton. Go watch those other videos. They're super cool. We use this so often in nature, it appears so often in nature, that this is called the natural log. So here we have the common log is a base 10. Okay, and then our natural log is a base E. Okay, and instead of writing log base E, what you will actually see is ln. Okay, so if you see ln, that is the same, it's a type of logarithm, it's the natural logarithm, and that means that its base is an E. So if you see the ln of 5, that is really the same as log base E of 5. Okay, so those are our two most common logs. The common log with a base 10 and the natural log with a base E. Okay, you can have logs with other bases, especially in coding. We use like log base 2 a lot, things like that. But these two will be very frequent, so keep an eye out for them. If it's missing a base, it's a base 10. And if that ln appears, that is the natural log. Okay, you also have an ln button on your calculator. So again, I'll show you on this one because this is what we use in class. But see right here, we've got log, and we've got ln. Okay, so this is your common log, and this is your natural log. That is actually the only two logs that your calculator knows how to do. So I'm going to show you one last trick to putting logs into your calculator if your base is not E or 10.